I think when we explore, we're kind of asking questions about ourselves as individuals and as a society, as a people. Neil Armstrong, I think, hinted at that with the words that he chose to say when he was going to set foot on the surface of the moon, which was one small step for a man, one giant leap for mankind. What he was hinting at was that he was carrying us with him in that exploration. I think curiosity carries us with her when she's on the surface of Mars. She helps us ask questions about who we are, how grand we are. What questions might we dare ask and hope to be able to answer?
After touching down on Mars, Curiosity drove away from Bradbury Landing toward a region called Glenelg, where 3 types of terrain come together. We were hoping that one of these terrains, consisting of light-toned and fractured bedrock, might teach us something about an ancient dry riverbed that we spotted from orbit. This river appeared to have started high on the rim of Gale Crater and flowed toward the site where Curiosity landed, spreading sediment in a fan across the crater floor. Even before we got to Glenelg, we began to see slabs of a rock called a conglomerate. By studying the size of the pebbles within the conglomerate, and by noting how rounded they had become, the team was able to conclude that they were carried by water ankle deep to hip deep, flowing at about walking speed and extending for at least a few miles. Curiosity actually set her wheels within an ancient streambed. Getting back to the present, Curiosity just finished drilling her second rock in Yellowknife Bay in order to confirm the remarkable discovery of an ancient habitable environment and to see if there's any variation among the rocks within Yellowknife Bay. We're now headed in the direction of our ultimate destination, Mount Sharp, 5 miles and several months away.
Out here in the Mars yard is where we develop the software that Curiosity will use to drive autonomously. We can test all kinds of situations out here. We can put rocks in its way and dig holes and watch what happens and see how it responds to different terrain situations. For the past year, Curiosity has been driving on Mars following instructions from human rover planners. But now we have a new capability that's coming online, something that'll let Curiosity drive herself on Mars. This is called autonomous navigation. Humans are still in the loop. We're going to tell her where to go. Curiosity is going to decide how to get there. Curiosity takes pictures from the navigation cameras with the hazard cameras. And it's able to combine that information, put it all together to find a safe way to get to where we asked her to go. And that capability is going to let us drive much farther than before. This is an animation showing Curiosity's first autonomous drive on Mars. The drive lasted about 10 meters, and you can see in the animation that she turned her camera this way and that to look at what's ahead of her. And you can also see that she didn't just go in a straight line, she actually curved a little bit to the right to avoid some of the small rocks directly in front of her. Another part of the autonomous navigation capability is using visual odometry. Visual odometry uses images from mass cameras to look at the terrain before and after a small drive step. Curiosity will see a few hundred features and see how they moved across the step. And by tracking those features, she can know exactly how far she moved, whether she slipped or twisted a little bit during the drive. And with that knowledge, the knowledge of where Curiosity is and the knowledge of what the terrain looks like, we get really strong information to drive safely into areas even that no human has seen before at enough resolution to know that it's safe.
Curiosity has continued to gather science data on her journey. She recently captured the 2 moons of Mars, Phobos and Deimos, in occultation. This movie shows the larger moon Phobos passing in front of the smaller moon Deimos and was taken using the mass camera telephoto lens. While we have now traversed beyond Glenelg, we haven't left this region completely behind. The rover is able to store samples in Chimera. Chimera is our tool for manipulating rock and soil samples and delivering these samples to our instruments. Curiosity processed a rock powder sample that she had carried with her for 75 sols from our second drill target. She delivered it to the SAM instrument located in the belly of the rover. SAM, or Sample Analysis at Mars, is our onboard organic chemistry lab.
We're flying in towards Mount Sharp, located in the center of Gale Crater on Mars. And to give you a sense of scale, Gale Crater has the diameter of the big island of Hawaii, and Mount Sharp is taller than the highest mountain in the lower 48 United States. As we descend to about 500 feet, we're going to be seeing some of the terrains that Curiosity has been exploring. To begin with, we're going to look at Yellowknife Bay, which is this arcuate rim of rock, a little cliff there, and that's where she discovered clays and an ancient habitable environment on Mars. But we had to drive there from where we landed, which is this mound-shaped hummocky terrain that was safe, and you can see how it's flatter. We landed right in the middle of that. Now in late 2013, Curiosity is driving her way through this terrain. It's kind of etched and rough and rugged. On the left, we also have a field of dark-colored sand dunes, and we're trying to find a place where there's a gap in the sand dunes because we don't feel it's safe to cross over the sand dunes with the rover. We'd rather do it on hard rock. We would guess that sometime towards the middle of 2014, we will arrive at this place where there's a break in the sand dunes. It's a place that's special to us because it represents interesting geology, and the topography is also interesting. We call it Murray Buttes, named after Bruce Murray, who was a pioneer in the field of planetary geology. When you look down here, you can see all these small buttes and mesas, and each one of those buttes is about 5 to 10 meters high, and each one of the buttes is about the length or width of a football field. You can see that sort of valley that goes through the middle of them there, and that's where Curiosity will wend her way through this rough terrain. We hope making interesting discoveries, and most importantly, signifying the transition between the first half of the mission, which was exploring the plains we landed on, and the second half of the mission, which is exploring the flank and climbing up Mount Sharp.
Hello, everybody.
Good morning, Mr. President.
I just wanted to call and say congratulations to the entire Mars Science Laboratory team. What you accomplished embodies the American spirit, and your passion and your commitment is making a difference. You guys have done an outstanding job. You made us all proud. Curiosity is going to be telling us things that we did not know before and laying the groundwork for an even more audacious undertaking in the future, and that's the human mission to the Red Planet.